Hello students! Today we are going to be talking about the Lilienfeld article that you read. So hopefully before this lecture you have read that article. You'll also need to read that before the discussion board post as well for this week. So this article covers a lot about the science of psychology, some of the common criticisms of why psychology is not a science, and some rebuttals to that, as well as admitting that there's some things that the field is doing not too well to help people's understanding of psychology as a science. So definitely go and read that article before you come and watch this lecture, as well as respond to the discussion board. But I'm assuming that you've read that now. This is actually pretty similar to what you'll experience in graduate school. There were only about 4 of my classes in grad school that had textbooks. Almost all the classes only used research articles. So we would be assigned a couple articles to read before class. We come and discuss them or do activities related to those research articles. There was one class there was like 4 research articles a week to read. And that was a lot when you're doing multiple articles for each class. That was a lot to read. But usually 2, maybe 3 articles a week are what we would do. And then if there was a textbook, it would be a chapter in the textbook and then 1 or 2 articles on top of that to get the most up-to-date information. So this kind of gives you a taste of what that would be like in a master's or a doctorate program. So let's talk about this Lilienfeld article. With this, there's a quote near the beginning of the article that talks about how psychology was not in Comte's original hierarchy of sciences. So the quote is, "Subject matter in psychology was unquantifiable and its methods were mired in metaphysical morass. Psychology has never quite lived this down, and as psychologists themselves like to say, has never recovered from its adolescent physics envy." So this is a interesting quote because at the time that this was written, there were fewer scientific measures in psychology. Experiments were we were still figuring out how to do things, so definitely a valid criticism at the time, but we haven't really recovered from that. And I also think it's a funny phrase that we haven't recovered from our adolescent physics envy, because as an adolescent, when I went into college, I actually started as a physicist or a physics major. So I thought I would go on to be a physicist and be doing science in the physics field. But in my first class, I took it, I failed out of that class, like literally got an F, it might have been a D, but it was a very low grade in physics, and I decided maybe I should do something different. Later on, I've realized now that the problems were with the methods of that course. That professor didn't allow you to use notes at all, and since I have a terrible memory for things like numbers and formulas, I couldn't get the formulas right on the exams, so my answers were wrong, led to me failing the class. I could have just taken it from another professor and had one that allowed notes, but I didn't realize that at the time. I didn't know much about doing school, doing college. I should have asked an advisor, but didn't do that either. So it wasn't until later I realized, I probably could have succeeded in physics, but instead I switched over to psychology because it was so interesting, and I really liked my undergrad, my 111 general psych class at the time, and I'm glad I did because I'm doing science in an area that I think is really interesting. So, but it's kind of funny that I went from physics to psychology related to this quote. Also, as a child, I thought I would do paleontology. So paleontology, physics, psychology, all things that start with P, and all sciences. So kind of funny. So with this, one of the things is that we don't really do a lot of work as professionals in the field to fix public perception. We could do a lot more. Some of the things we've talked about in other class that are repeated in this article, there's some new ideas in this article as well. But because of this, because we don't fix this perception, some people are reluctant to seek psychiatric help. If you're holding a psychologist counseling you at the same level as, say, an astrologer or a fortune teller or something like that, well, if you're not likely to see one, you're probably not likely to see the other as well. So not knowing it's a science similar to medical science increases that hesitancy, increases stigma. So people who don't see psychology or therapy as scientific, it adds to the stigma around it. So with this, psychologists can also get a lot less STEM funding, or they tend to get less STEM funding because of this. So if there's federal grants and whatnot, there's a lot more that are given out to other sciences rather than psychology. Now, when that happens, so with this, oftentimes psychology kind of research is absent from funding lists. So if there's a grant that multiple kind of fields can apply for, psychology might be excluded from being able to apply to that. Now, more money can lead to better and faster research. It doesn't always mean better and faster research, though. So you can do a good study for less money or a good study for more money. In psychology, with my experience, depending on the kind of methods that you're using, generally the more money can lead to a little bit better tools or a little bit faster research. But just having more money doesn't mean that the research will be better for sure. You still need to use good methods, and we'll talk a lot more about methods specifically in the second unit of this class. We'll touch on it a little today. So, and then also, psychologists might get less funding because politicians not understanding psych as a science. If they don't understand the utility and the usefulness of psychology, they might completely discount anything a psychologist says in encouraging policy change, for example, to help with any kind of social problem. So with this, again, less money and less use of psych in policy and evaluation. Oftentimes, economists and their models might be used or held to a higher standard or seen as better evidence for should we or should we not do this kind of social program than what psychology research says. So oftentimes they say the same thing, though, which is interesting, that, say, helping people will help all people in the economy. But yeah, helping people is a kind of the focus of applied psychology and evaluation. And if you're not having people listen to those professionals and those experts because they don't see psychology as a science, it can be really hard to get those things changed. It's not the only problem in talking with politicians and getting policy level changes made, but it's one of them. So with this, a lot of lay people already believe they have adequate training in psychology. So some research back when this article was written was that about 83% of people thought that they had adequate training in psychology. So where did most of their knowledge likely come from? Think about the places that people are getting things, or the bookstore where you might see psychology in the psychology section. So where does most of their psych knowledge come from? Probably a lot of it is pseudoscience or maybe common sense psychology. Now, common sense psychology can, in some cases, turn out to be accurate. But we'll see some other examples where it can also turn out not to be accurate. That's why you've got to do the science. You have this idea, whether it came from common sense or from a theory. You test it, you see if it holds up, and then if it doesn't, you know what the actual answers are. So with this, experts in psych are perceived to not know much more than the average person. So if you already feel like you have an adequate training in psychology, you already know enough, then why would you listen to an expert? What are they an expert in? What did they go to school for so long? Probably that's what my parents ask of me still. With this, there's actually an interesting example of my mom and my sister. My sister has a bachelor's level education and does work with children in an applied kind of setting. I've also worked with children in a similar kind of applied setting, but I've also had more advanced degrees and done more research on child development, adolescent development, and adult development. So it's kind of my area, is pro-social and moral development of humans. So I know a little bit about this. I wouldn't put myself on the level of expert, but I'm working towards that. Definitely know a little more than my sister. But when my mom has a question around child development, she goes and asks my sister about it, even if I'm in the same room. So say at a Thanksgiving meal, they'll ask my sister about it rather than me. Which, I mean, maybe that just goes to show my mom and my sister might just have a better relationship. But when I try to chime in things with research, maybe I'm just not as good at sharing research in that kind of context. But it's interesting that my mom will go to my sister for that information, even though I know those things as well as more things. So with that, it also shows, demonstrates how some people don't feel like the knowledge that I'm bringing as more of an expert in this area is as valuable, because they already have enough training. They already know enough things. So not to say that my sister's not trained, but that I've got a little bit more training. So I find it a funny example. So with this, people also remain unaware of how many broad topics psychology can impact and knows about, how much research there is. So we've seen this model before, the bioecological systems model. So here we have an individual child, one individual parent. You could have a whole other circle here for a second individual parent. You could make this a parent system, their marriage network, their work network, social network, school network, but you also have community here. So what are things in the community? Well, probably churches, businesses, schools, organizations, the local politics. You've got society. So the larger society around them, culture as well, even around that. So any of these different aspects, there are studies of culture's effect on children's cognition. That one would be really easy to find. Culture's effect on how parents parent children. Culture's effect on the social networks of a child interacting with the parents and the parents between the social networks. So you can find research on all these things, applied research, basic research. And so psychology knows a lot of things that can impact daily life of all people. So with this, physical health, mental health, worker productivity, workplace well-being, economic problems, economic systems, the environment, activism, community engagement, popular culture. There's a lot of things that psychology knows about that we could share, that we could help improve. That's one of the things I like to try and do as an applied psychologist, is try and use the research to actually make impacts and make changes. But when we're fighting against this kind of public perception, it can be difficult to actually make changes. So with this, in the book, in the Lilienfeld article, they reference a lot of common sense psychology and how people might see psychology just as common sense. These are a couple things from the article itself that are common sense, but research shows is not actually the way things work. Like expressing pent-up anger reduces anger. You might have heard someone say like punching a punching bag or punching a pillow can help reduce your anger. It actually doesn't. There's a lot of research that shows that that actually doesn't help reduce the anger at all. So that's something common sense might say, but it doesn't actually turn out to be the case. So there's this book also by Lilienfeld, The 50 Great Myths of Popular Psychology. So here are a couple from a couple of the different chapters. We're not going to go over all of the myths in the whole thing, but I just wanted to let you see a few of them. So in chapter 1, people use only 10% of their brain power. This is one that I usually get at in a 100 level class, so a general psych class, that we use essentially all of our brain all of the time. So maybe not 100% at any given time. If that was happening, you'd probably be having a seizure. But a massive amount of our area of our brain. People aren't left-brained or right-brained. They're basically one of the only things that the left versus right brain does is the left side of my brain is affecting. This is my right hand. I can't tell which way I'm recording it, but this is my right hand. The left side of my brain is controlling its movement as well as any sensations it's picking up. So those are different. The language processing center is in the left hemisphere of your brain, but it's also using other parts of the right hemisphere. The corpus callosum is a big set of axons between the two hemispheres of the brain. Hopefully you remember this from talking about some neurology, but there's no such thing as left brain and right brain. Talking about childhood development, playing Mozart to infants boost their intelligence. That might be something that you've heard from people. Doesn't change anything about intelligence. Actually, one of the best things to do when an infant's in the womb or when a when they're in the womb or soon after birth, is talking to a child. So that's one of the best things. Their brain's actually really primed to learn human language, any language really. Multiple languages is even best. So if you have a bilingual family, speaking both languages can be really great. But yeah, the music thing, doesn't matter if it's heavy metal, doesn't matter if it's classical, music doesn't really make any difference. So adolescence is a time of trouble and turmoil for people. That doesn't tend to be the case. On average, adolescents are feeling emotions stronger than they might have at other times of their life. But generally, this is kind of a perception that comes from older people that look at the adolescents and are like, oh no, they're going to be doing things like having sex and doing drugs and having lives outside of our adult control, and be afraid of that. It's kind of a pattern that continues on with each generation of teenagers. Midlife crises, on average, don't happen. Opposites attract. We actually tend to be attracted to people who are pretty similar to us. So not identical, but pretty similar. Men and women communicate in completely different ways. No, there's not really a sex or a gender difference there. Different people might communicate in one way or another way, but there's not a sex or gender difference there. Most mentally ill people are violent. Almost no mentally ill people are violent. People with mental illnesses tend to be targets of violence a lot. But yeah, almost no mentally ill people, statistically speaking, are violent. Criminal profiling is helpful in solving cases. Probably go and read that for more detail or learn more about it in, say, like a criminal psych class. Criminal profiling is not very useful in the ways that it was used in the past. And when we're talking about criminal profiling, you can definitely look at research on criminality and what are the contexts and the features that lead people to commit crimes. Surprise, surprise, things like not having enough food or resources in your area to take care of your needs and your family's needs make crimes more likely. So things like that are what we can look at and try to solve those problems in ways other than just putting people in jail. So virtually all people who confess to a crime are guilty of it. People will confess to crimes for a lot of reasons. Some of those reasons are that they're tricked into confessing for it. There's a lot of different reasons, but yeah. So those are just going really quickly through a bunch of these common sense things that you might have heard. Oftentimes people have heard of these two, the 10% of brain and right versus left brain. You, even up to today, right now at this point, you might have heard that and thought that in the past. So good, we know now that those are not the case, and you can go forth and let people know a little bit more about the science of psychology and look that up. Start maybe APA website, look up research articles, Google Scholar. Very soon in this class, or maybe just recently, you would have also learned how to find peer-reviewed research, so you could look that up for it. So, even though you might have believed these myths, that's totally okay. A big part of this class is teaching the science behind these myths. I often try to get at a lot of these myths in my own general psych class to help people understand right at the beginning of psychology some of these myths and debunking them. But with this, a big part of this problem is that we psychologists have work to do to fix a lot of these misconceptions. So one of these misconceptions is that psychology doesn't use a scientific method or scientific methods. We've already covered this in a few ways, but a lot of this class, especially when we're talking about the actual methods that we use in the second half of class, really focuses on what are the scientific methods that we use specifically in psychology. So a randomized control trial, or an RCT, is a double-blind experiment. Well, you can also do an RCT that's a single-blind experiment as well, but they're also often seen as kind of the gold standard, like what you want to do in psych to see if some sort of treatments work. So what is a single-blind experiment? What is a double-blind experiment? So maybe write down in your notes really quickly, what you think or how you would describe a single blind experiment, and then write in your notes how you would describe a double blind experiment. All right, hopefully you paused the video to write those things down. So a single blind experiment, the participant doesn't know if they're getting a treatment or a placebo. In a double blind experiment, the researcher and the participant, neither of them know if what the participant is getting is the placebo or the treatment. So that's pretty easy with, say, a drug. You have a bottle of drugs that the computer knows, is this specific bottle the placebo or is this not the placebo, and then you give it to the participant, so the doctor who's giving it doesn't know. As for psych treatments, if you're doing a face-to-face thing, you might only be able to do a single blind. So the researcher giving the treatment or the therapist giving the treatment would know, probably, unless you're doing something like an online treatment. So I've done experiments that are double-blind experiments where I set the computers, say, okay, randomly have 50% of people do this set of activities, have 50% of people do this set of activities. So the computer sends them that way. The computer doesn't care. It's just programmed to send 50% one way or the other. And so I will get a result of some people were in the control group, some people were in the treatment group. So that's how I've often done my double-blind experiments, because I don't have really any interaction with the humans. No interaction like face-to-face. Sometimes there'll be something that messes up and they'll email me or something like that, but that's about as far as it goes. So with this, another perceived problem in psychology, and experiments are not the only method that you can use in science, but it's seen as kind of a gold standard. People understand experiments are scientific, so just one example of how we're using the scientific method. So another perceived problem is that psych cannot yield meaningful generalizations because everyone is very unique. And that's true. Even if you take people that are twins, they are very unique. So identical twins, even with very similar genetic structures, it's not always exactly the same, like down to, and we're talking about like very much narrowed down to individual genes kind of thing. So even identical twins are unique. They're growing up in different situations. Maybe they had different first grade teachers. So everybody's unique. So how can we know anything? Well, that's where this model comes into play. We can look at the relationships between these things. We can see on average, or like it's more statistically likely for X, Y, or Z to happen, or it's more statistically likely for A, B, and C to happen. And some of those individual differences also aren't going to matter for whatever we're measuring. So one way to say this is unique variables may be largely or entirely irrelevant. So those pieces that are unique might be completely irrelevant to the underlying mechanisms of the treatment in question. So whatever we're studying, whether it's a treatment or whatever it is, let's say we're looking at depression and we have a new treatment for depression, we're trying to help people with that. Their genes for hair color is probably unique for each of them, but it probably doesn't matter at all for our treatment for depression. It would be very unusual if it did, right? So a statistic way to say, or way you would say this in stats language, is that the unique attributes of each individual may not interact statistically with the intervention, but may be swamped out by its main effects. So you might still be able to see a main effect of your treatment on whatever outcome measure, and those other interacting things might have no statistical effect, essentially, because they didn't matter enough or they didn't change things enough. But we want to find like what things do actually change any given relationship. When we look at this model, what's the most important for a child's happiness? Well, is it their biology, so like their genetics? Is it their own behavior? Is it their parents? Is it their friends? What are the main effects or the main things that are going to affect, say, a child's happiness as they develop? So again, their hair color genes are a unique variable, but might not matter at all. So let's look at something that might make a little more sense. You might have a little bit more familiarity with. So weight loss. So you're trying to lose weight. What are some main variables that might affect losing weight? Well, diet, exercise, your age might have a factor, sex might have a factor, right? Because different biologies will hold fat in different ways on average. So, but also hair color genes. Might those hair color genes interact in some way? Maybe. I mean, I guess it's possible that those genes are related in some way, but what's going to have the biggest effect here? Well, diet and exercise probably, right? So also age. So diet, exercise, age, those are all going to have a lot more interacting features than, say, hair color genes. So yes, everybody is very unique, but those pieces that are unique might not matter depending on what we're looking at. And then when we're looking at it in aggregate, on average, we might be able to find a lot of things that are meaningful results. So we can make some meaningful generalizations. And that being said, that doesn't mean that we ignore everything that might possibly be unique. Culture is one thing that was ignored for a long time. So hopefully you went over this in your general psych class, but a lot of the history of psych research was done in the Western world, specifically the US, and even earlier it was also done specifically with white young men. So does that specific group, do all the findings there generalize with everybody in the world? Well, of course not. So if a treatment works for middle-class white young men in the US, is that going to work for someone who is not white and poor in the US? Well, probably not. Or maybe, but we have to find out, right? We have to do the work to investigate what are the variables that are affecting, what are some meaningful generalizations that we can make. So again, some things like hair color genes might be unique, might matter, but they might not as well. We have to do the science to figure out what is it that matters, what can we intervene on, what can't we intervene on. So the arrows here are examples of how one relationship might affect another relationship. The strongest effects here, so like the stronger effect of like a parent's relationship to a child, that might be more important than, say, friends' relationships with a child on any given variable. So those strongest effects might generalize across multiple people, even generalize across culture, depending on what you're looking at. So with this, another perceived problem is that psychology does not yield repeatable results. And so this is not all of this, but a lot of this is down to the tools we use to measure in psychology. And we'll talk in a lot of detail about reliability and validity as we get to the second half of this class. But these pictures here are basically examples of some ways you could measure happiness. So this one is you're measuring someone's smile. So would that be a very useful way to measure happiness? Well, probably not. People can make a smile even if they're not actually happy, right? So an actor does that a lot, right? Even if they're not happy, they might be able to smile and look like they are happy. So maybe not the best measure there. You might have seen something like this when you go to a doctor's office. Maybe if they ask you about the pain level you're experiencing that day. I've got a lot of experience with that recently after my surgery, asking what's your pain level to? Or even I was at physical therapy last night and they're like, how has your knee been? What, as you're doing your exercises, which pain level are you at on a scale of 1 to 10? Another way we could measure happiness is by looking at hormone levels. Oftentimes we do that with, say, a cheek swab, just because it's a little less invasive. You can also do that with, say, like a blood draw. The blood draw gets like hormone levels that are more, so you make a quick change and then you get a quick assessment of hormone levels. Say the skin cells of a cheek swab, it's a little more delayed for the hormones to get into those and then shed off the side of the skin. So depending on what you're doing, you might need that blood draw, you might need the cheek swab, you might do a survey measure, but these are all different tools we're using to measure certain things. So the fact that we haven't always had repeatable results, some of that is down to methods problems, some of that is down to the tools that we're using. So with this, the control or lack of control over any kind of variables can also impact results. So if we don't know that there's a third variable that's more important, let's say we're testing our depression, our new depression treatment, right? So we have people, we have our new depression treatment, and we're trying to give it to them, and we're not taking into account that some of them are in poverty and some of them are not in poverty. Those ones in poverty might have a harder time even with this new depression treatment. So if we don't take that variable into account, we might not see repeatable results when testing it in a new sample. So maybe we've used only a middle class sample, and then we try to repeat it in a sample in poverty, and we see completely different results because the bigger effect would be the poverty in this case. Maybe our depression treatment can't overcome the challenges of being in poverty. So with this, measures like the measurement tools we're using are getting better. The methods we use are getting better. They've gotten better a lot for years and years, and they're getting better now. So with that, we are doing a better job at getting more repeatable results. You can think of it as, let's say you've got a microscope. So microscope technology wasn't always as good as it is today, right? So you might see something in one microscope that you don't see in another microscope because your measurement tool was not as good. So that's kind of where we're at now. We're making better tools. We're using better methods. And as we do that, we can get a lot better, more repeatable results. So, but people might not know that, what the more recent research looks like, especially if they're thinking like Freud or Skinner are the psychologists that we look to now. So it's already a lot better than most people assume. So another perceived problem is that psychology can't make precise predictions. So we just talked a little bit ago about how there's so many variables, but that some variables aren't going to matter. Some might change things, but you have to really investigate how they are going to change things. Much of this is because people don't understand a lot about probabilities. A lot of sciences use probabilities in getting their results. So one good example of this is the probability of having an earthquake in a specific location. Well, you've got the variables that you know of things like fault lines, when the last earthquakes were, how much the other plates around it are moving. So these are multiple variables. And so you can make a prediction that, well, it's likely that Yellowstone is going to explode and kill us all in the next 100,000 years, right? Something like that. You can make a probability prediction. So with that, that might not be as precise as you might want it, but in some cases we can make really precise predictions even when we're using probabilities. So there might be a 10% probability the earthquake will happen tomorrow, or if you see that there's a 70% chance of snow tomorrow. What do those numbers mean? Another example of this is you might have two studies in psych. One finds that about 15% of children of divorce have negative psychological effects. And we'll just use that as kind of a general, broad thing. Anything you classify as negative, about 15% of people, and I just made these numbers up. These aren't actually from a study. A second study finds about 25% of children who went through a divorce experience some negative psychological effects. Well, what's right? Is it 15? Is it 25? So what's the truth here? What do these numbers indicate? Well, let's say this first study was a study of 500 people and this was a study of 5 million people. Well, I'd probably be more likely to count on that 25% number because it was 5 million people versus 500 people, or maybe it's somewhere in the middle there. So while we might not be able to predict every single specific thing yet, maybe at some point in the future we can do a lot better job at that. So can we run a true experiment here? Can we have a control group of children who never go through a divorce and a treatment group of people who do go through a divorce? I mean, you could, I guess, but how are you going to actually do that ethically, and how are you going to make parents get divorced? So like, assuming you had some kind of omniscient power, yeah, you could run a true experiment there. But in practicality, no, we can't run an experiment there. We can only make more and more precise predictions based on these probabilities. So most psych studies are probabilistic or written as probabilities. Many, especially more newer research, should include confidence intervals. So saying, hey, our group increased this much, 10 points. But our confidence interval for the general population is that people will increase in between 8 and 12 points. So you see here's maybe group 1, maybe this is your control group and their final happiness score after your depression treatment or something. And this is your treatment group. So this is where your group landed, your treatment group. So they're more happy, they have a higher happiness score. But depending on how many people you have in the sample, you have what's called a confidence interval. So you're pretty confident that most people, and this is again just probabilities, you're pretty confident that most people would fall in here after doing your depression treatment. Your control group was here, and you're pretty confident that the general population would fall somewhere in here. So that is one really good way to do some research. One way I've talked about some probabilistic results is that in my purpose, or the group I worked with, purpose training activities, 75% of students increased their searching for purpose. So most students were actually searching for their purpose throughout the activities. They were actively trying to work for it, and by the end of it, about 50% of them showed an increase in having attained or identified their purpose in life. So that's about half of them did, about half of them didn't. So that's, again, probabilities. I can say, well, I can predict that out of 4 people that are going to do these activities, I can predict that 3 of those 4 people will actually be searching for their purpose, and I can predict that about 2 of those 4 people will probably actually increase their purpose in life. So with this, again, some findings are context dependent. If we do this in a US sample, we might not find the same thing in a Chinese sample or a sample from Mexico. So those are actually 2 of the locations we're working to translate and make the activities different for, to test in those specific areas. So we can't just assume it's going to hold true in completely different cultures. So we're going to test, hey, is this about the same results there? Does it do a better job in other cultures? Does it not do as good of a job? And we're working with people from those cultures to make the changes to be relevant in those cultures. So with this, some variables can't be controlled. So ethical or practical challenges, you might not have the capacity or the money to make changes or to control all variables. Ethically, like the example earlier, you can't make some groups get divorced and other groups not get divorced, right? That would be a very unethical thing to try and do. So with that, you might have some general predictions, but you can also have some really precise predictions depending on what exactly you're researching, depending on the measurement tools that you're using, the methods you're using. We can, as psychology, get some really precise predictions. So another way we do this also is meta-analysis. So let's say you have 20 studies that are testing your new, so 20 different groups around the country or around the world are testing your new depression treatment. So you can take the data from those 20 different studies and pool it together in what's called a meta-analysis. Basically, it's a quantitative studies that combines all the data and findings from those previous studies to get a more precise prediction. So if we do 20 studies around the world, that's a lot better than one single study anywhere. Right? So we take the data from those 20 studies, we combine it all and say, okay, so with the bigger sample that's worldwide, we can predict that the actual response or the actual results will be something more like this versus this or something like that, even though one result might be a little different in one specific place. So this is often done with randomized control trials and experiments like this. So another perceived problem is that psychology is not very useful to society. And we talked about this a little bit more with all the context that psychology does affect and can impact. And most here in this class probably realize that this is not the case. That's one of the reasons that you're going into psychology, that you realize, because you realize it can be really useful to people. So we could, as a field, do a lot better job with sharing examples of how psychology applies to society. So there's a reason there's a picture of fire trucks up here. So research in sensation and perception from psychologists showed that one of these trucks was a better truck to have for a fire truck. It led to less accidents, more people saw the fire truck, more people could avoid a fire truck or moved over for it so that the fire truck could do its job to get to a fire. So which one do you think it is? Well, it's this one. If your city's not using one that looks like this or has a lot of yellow striping like this, maybe that's something to work on in your city to get them to have updated paint schemes, because this is a lot easier for our brains and our minds to ignore. Something like this high-vis yellow bus, or also you might see like high-vis green or kind of an orangey hue. Those hues are attended to by our brains a lot more than the red, even though it's a really classic color. So you might have, say, one fire truck to like put out for pictures, but hopefully most of your fire trucks that are actually doing work are looking more like this. And that's one thing that psychologists found and can make a change in society to literally stop fires. So other things like operant conditioning that you hopefully remember from your general psych class. That's useful in training animals. That's useful in helping to train children as well, giving them reinforcements. So assessments or testing, so making better measures, can be really useful for, say, jobs or college admissions. Not to say that the tests that are used for college admissions are always the best, but we know from psych research ways to make them better. Doesn't mean that the college system has adopted some of those better measures. Voter turnout and voter behavior. So if we want more people to get out and vote, we have research to show how we can get that to happen, how we can encourage people to vote or make it more likely that people will vote. Things like that you might have even heard of in the news, of having more polling locations can help people. Making it easier for them to do mail-in voting can increase voter turnout. So other things to do within campaigns or to change things around how media discusses campaigns can help improve voter behavior and turnout. So memory and the law. So there's a lot of research in, say, eyewitness testimony that shows that eyewitness testimony, even though it's one of the things that a jury tends to emphasize and lawyers tend to emphasize, having a story like, oh, I saw this happen. Eyewitness testimony is not a very reliable source. Remembering exactly what you saw and all the little details can be really easily manipulated by someone asking some very specific questions. So decision making of humans, of me and you, is not as rational as we wish it were. So we might even, especially as a scientist, this is a hard one to hear and think about, because we like to think that, oh, we know a lot of research, especially as a psychologist. I know how my brain works a little better so I can make rational decisions, but we don't always make rational decisions. We're very often, it kind of goes to that left brain, right brain thing, and the not only using 10% of your brain, you're always using aspects of emotions and that emotional center of your brain as you are making a decision. That's not to say that all decisions are entirely emotional and not at all rational, but you might be surprised at how much of our rational decision-making process is not actually rational. Workplace well-being is a big area of research. So doing an IO psychology program, you'll read a lot of the research on how to help a workplace be a more positive place where better communication between different people, coworkers and managers and things like that. So it tends not to be like adding a ping pong table to the organization. Things like actual training and how to communicate well, and having more options for communication. Having options for communication that's anonymous can help too. Things like that. So there are a lot of applied problems that psychologists can do research and have done research to improve psychology. So maybe pick one of these or pick one of your favorite examples. So if you find someone who says that psychology is not useful to society, talk about one way that maybe psychology is useful to society. So with that, this also gets to basic versus applied research, which we haven't really gone into a ton of detail yet. Basic research kind of looks into answering questions for the sake of answering questions, figuring out, well, I want to know, how does the memory work? How do human memories work? That's pretty much a basic research question. But an applied research question might be, well, how does memory work in relation to viewing a crime? Or how does our understanding of how memory works apply to viewing a crime and testifying around that? So some of this is basic versus applied research. You might not get in a specific basic research. The researcher themselves in their paper might not be talking about applications of their work. They might just be trying to figure out how things work. But let's look at some examples of some studies. This isn't specifically psychology studies, but let's look at how the scientific method was used, how data was collected, and all of the different kinds of ways that it could be useful to society from what I think in the beginning might seem like a really silly, maybe useless question. So the question of, can you snap with a metal glove on? So that might seem like a really silly question. Like, what use could that be? Why does it matter if you can or cannot snap with a metal glove on? Well, let's see what the study found and how it could be useful.
Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/SciShow to learn how you can take your STEM skills to the next level this year. A snap of the fingers is a metaphor for something easy, like you can do it in a snap. But researchers who really buckled down to study the physics of finger snapping found it's actually a pretty impressive feat, and understanding it could help us study things from insect jaws to prosthetics. In a study published in 2021 in the Journal of the Royal Society Interface, researchers figured out the physics of the finger snap using high-speed cameras and force sensors. The inspiration for the study came after seeing a movie where the villain snaps his fingers while wearing a metal glove. 6 guesses for which one that is. The researchers wondered...
So this, I think, goes well into, well, why do we ask research questions? Sometimes research questions can come from examples like this. Maybe you've seen something in a TV show or a movie or read in a book that you're like, hey, well, would human beings actually behave that way, or things like that. This has inspired a lot of psychology questions. So I think this is, it seems like a silly question, right? Like, could you actually snap with a metal glove on? It seems kind of silly, but there's a lot of application that you could make from that. Again, if you're doing just basic research, it's not necessarily your responsibility to find the applications. It's okay to study something just to understand it too. That's one of the valuable things about science is the more we know, the more that maybe someone later will come and see, oh, because we know this, this is really useful for this new problem that we're facing.
Whether it would actually be possible to do that snap because the metal wouldn't have much friction. Well, according to the study, the perfect snap can be broken down into 3 phases. The first is loading, where the thumb and middle fingers store up kinetic energy or energy of motion. Then comes the unlatching, where the fingers start to slide past one another. And finally, unlatching movement is when the fingers move at ultra-fast speeds until the middle finger hits the palm, creating shock waves that make the snap sound. The whole thing happens in less than 7 milliseconds, 20 times faster than the blink of an eye. And during that unlatching movement phase, your fingers are rotating at up to 7,800 degrees per second, almost as fast as a professional baseball player rotates their arm during a pitch. All this means finger snapping is one of the fastest, most explosive movements our bodies can muster. But what?
So that goes to learning something, right? That might be something that they wouldn't have known without looking at the physics and biology behind finger snapping. They wouldn't realize how dramatic that behavior is. And it seems pretty simple. It's something that a lot of us can do. My 4-year-old learned to do it pretty recently and does it pretty frequently now. But it's a pretty amazing feat and for a lot of different biomechanical reasons. So they're not necessarily talking right now about how that could apply, but that's useful knowledge. It's interesting knowledge to have. And that could be considered knowledge for knowledge's sake. You could just stop that basic research right there. And some questions in psychology that we might ask to realize, well, how do things work? Like, how does the brain work? How do we store memories? We might not have an application for it immediately, but understanding these things can be really useful.
Whether those 3 phases add up to a snap or silence comes down to one key element: friction. Friction is the resistance between two objects moving over one another. And it turns out that snapping requires a sort of Goldilocks zone of friction. You see, you want friction to help build up the kinetic energy in the loading phase, but you have to overcome the friction when it comes time to release during unlatching. Researchers figured out just how much friction contributes to snapping by rigging how slippery and squishy a person's fingers were. To make them more slippery, participants in the study wore lubricated nitrile gloves, and when they did, their fingers didn't create enough friction and they could not store up enough energy for a forceful and loud snap. If their fingers were instead made more grippy by wearing a latex rubber glove, then participants couldn't release their fingers and the snap also flopped. The researchers, they did, their fingers.
So going back to this goes back to the kinds of tools that we have in psychology. So these kinds of high-speed cameras to be able to watch and measure this, it looks like on these fingers also they have some markings to help maybe a computer program track specific joints in the finger as well. Without those tools, we couldn't necessarily answer this question in the same way, right? So building better tools, getting more reliable or more useful tools can be a better way to get things like a more reliable result or a more specific result. So these scientists figured out that Goldilocks zone. What is the range of friction you need to be able to have a snap, right? I mean, we probably understand this on a maybe common sense level that if there's too much friction, you can't make that snap. Whereas I just snapped, or if it's too slippery, you wouldn't be able to snap. But when you have that kind of very specific kind of measurement tool, you can get this kind of specific result and find that exact range. And that's what psychology is doing as well. In many cases, we have tools good enough to make those really specific predictions. In some cases, we're still improving those tools, but we have still a range that we understand around.
Fingers didn't create enough friction and they could not store up enough energy for a forceful and loud snap. If their fingers were instead made more grippy by wearing a latex rubber glove, then participants couldn't release their fingers and the snap also flopped. The researchers also wanted to see whether the squishiness of someone's fingers or how compressible they were had anything to do with the friction that built up. So some participants wore a hard metal thimble with a nitrile glove on top, and it turns out fingers need to be at least a little squishy to help build up that friction. So snapping with a metal glove on, not possible for people, maybe possible if you have infinity stones or something. The researchers, who had previously studied superfast motion in other animals, took all this information and combined it into a mathematical model that could now be used to help in other fields of science.
So they're making a mathematical model. It sounds complex. Mathematical models can be very simple. A correlation is a mathematical model of how two variables are related to one another. So if I give you 1 scoop of ice cream or 2 scoops of ice cream or 3 scoops of ice cream, is that going to increase your happiness? How much does your happiness increase? I could find a correlation between that. Maybe there is a correlation, maybe there's not. I would suspect that there's probably some correlation there. That's a simple mathematical model. In psychology, we also use things like regression equations. That's a more complex mathematical model. Structural equation modeling. That's an even more complex mathematical model. And these are the kinds of mathematical models that they're talking about here, that psychology uses, physics uses, chemistry uses, biology uses. These mathematical models are part of one thing that we do in science to try and predict certain outcomes, or be able to have a better understanding of when or where will these outcomes occur.
For example, it could help biologists understand the snaps of, say, Panamanian termite soldiers. Those are insects that snap their jaws together ultra fast to defend their hive, and the researchers proposed the mechanism might be similar to finger snapping. Plus, understanding the dynamics of the finger snap could help engineers fine-tune the movement of prosthetics. Which you gotta say, isn't just fun, but pretty snappy research indeed. It's funny how we don't really understand things like finger snapping until someone goes, but how does that actually work? And they decide to do some science about it. But to learn more about the physics of the everyday from...
And so that last point in the video, I think, is one of the big points about this class and this article that we're reading as well, is that there are so many everyday things, like you were saying, that seem normal, that we seem like we might have common sense around it. We might have an understanding. We might even feel like we have a general understanding of how people work in specific ways. But until we do some actual research, some science, and test things and figure things out, we might be wrong in our assumptions. We might be wrong about our common sense psychology. We might be wrong about what we think is actually how things work. And so figuring out how things actually work is really, really useful, because then if we know how they work, and maybe we can solve problems, maybe we can build on or use things. Memory tips, if we didn't know all those memory tips, then that wouldn't be as useful, right? So I've given you a lot of memory tips in this class. I try to do that in all my classes, really, to help you do better in your studies. So if we didn't actually look at, well, how does memory work? What things do people pay attention to? We wouldn't have those tools. So that's another example of a practical thing that psychology does that can be that is really useful. So psychology is useful to society. Again, probably all of us in this class wouldn't be here in psychology if we didn't think it was already useful. But hopefully now you've got a lot of examples to kind of share with people about how is psychology useful to society. So with this, some of these misconceptions can be fixed because we've got to do a better job policing it, policing ourselves as psychologists. So if we do a better job, we can hopefully fix some of these misconceptions and they don't continue into the future. So we need to do better as psychologists about consuming and using science. So how do you consume science? You read research articles, you read books, you do the science yourself. You use it by doing more science or applying it in a specific context that it might not have been tested before. So we can train upcoming psychologists better in science. So that's part of what this class is for, is to teach you to be a better consumer and applier of science. So especially in clinical practice, because if people need therapy, we don't want them to be avoiding it because they don't think it's scientific. That would be really awful. So we definitely need to do a better job about emphasizing and using science in treatments. So just yesterday, there was a really good example of this, not in psychology, but my physical therapist. So there was a person training in their medical degree. So they're earlier on in their medical degree, they're training to be a physical therapist. So I'm doing one of the exercises that I've been instructed to do, and the physical therapist says, okay, take this rubber band that was around about my calves, and they're like, actually put it around your feet, so you're stepping on it as you're stepping side to side, to increase some of the strength in my hips, basically. And the assistant person, the person who was training, so the new person learning this clinical practice, being trained, they asked, oh, why did you do that? And my physical therapist said, well, more recent research, like a couple specific papers that they cited, said the further away you are from the lever, the more useful it can be for muscle gain. Makes sense. I can tell you from experiencing it firsthand, it was a lot tougher to move my feet side to side there. But that was a good example of training that upcoming person in the science, in the recent science. And that's why, like I mentioned at the beginning of this, in graduate classes, you'll often be going just from research papers. You might have a book, you might not, but you'll be reading a lot of research papers because it's the newest stuff in the field. Sometimes you'll read older papers and then compare to and follow the track of what measurement in a certain area has done. But a lot of what you're doing in getting more advanced training is seeing what the most recent research, what the most recent science is doing. Then actually for doing your PhD, you have to be at the forefront. For doing your dissertation, it should be something at that cutting edge of you're doing something new here. So with that, we need to do a better job even in the undergrad for training young people, or anyone taking the classes, honestly. It's not only young people. For anyone training to be a psychologist, to understand the science that we're using. So just like this medical professional that I was talking about, mental health professionals need to be good consumers of science, need to be able to evaluate that science, need to be able to create science and do science themselves. So we also could do a better job about changing the public face of psychology. So Dr. Phil, I don't get the sense in the general populace, Dr. Phil's as popular now. Maybe I just hear less about it. But we can change that kind of public face. When people think of psychology, hopefully they're not thinking of Dr. Phil. Maybe we have them thinking about Phil Zimbardo, who was the APA president in 2002. You might have heard of the Stanford Prison Study, currently doing heroism research and supporting heroism research. So, but also, there's even more recent researchers. It doesn't have to be a Phil either. So it's just, I thought, a clever example. We've got Dr. Phil, we've got actual Dr. Phil Zimbardo, but it doesn't need to be a Phil. We probably shouldn't have the face of psychology be an individual person anyway, because there are so many different fields. Like Dr. Zimbardo, pretty focused on social psychology, did research in heroism, did research in time perception, like how do we perceive like the passage of time and how that affects things. So what are other ways to change the public face of psychology? You don't need to teach an entire research methods class to convince someone about the scientific nature of science. Some people it might take an entire research methods class to understand that. At least I get that feeling from a few friends who I try to explain sometimes that psychology is a science too. But you don't need to teach them an entire class. You can give them a couple examples. So if there's any questions that you have from the article that you want covered, email or put it in the discussion boards as well this week. So hopefully that clears up and can help you as a psychologist and a scientist understand a little bit more about the science and be able to share a little more about it. So that is it for the Lilienfeld article. Again, hopefully you read it before watching this video, but also this will give you a little more good information going into your discussion board as well.